NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. After months of spouting gibberish, the spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
Voyager 1, after 50 years in space, has made an impossible discovery. Launched in 1977, it has ventured beyond our solar system, revealing shocking secrets. Scientists are stunned as this changes everything we knew. The mission was meant for 5 years, but has lasted nearly 50. Tune in to find out what happened in those years. The spacecraft that refused to retire. In 1977, two ambitious space explorers embarked on what would soon become one of the greatest feats of exploration ever attempted by humankind. Their goal? To reveal secrets about our solar system that could change everything we know about our place in the cosmos. And that is exactly what they did. The missions of these twin pioneers have become legendary. They did not just give us close-up images of planets we had only dreamed of understanding. They have been sending back jaw-dropping information about interstellar space for over 4 decades. That is right. 47 years and 24 billion kilometers later, they are still out there. Still teaching us things that seem downright impossible. One mysterious signal remains unexplained, hinting at something beyond our understanding. These two spacecraft are more than hunks of metal flying through space. They are symbols of curiosity, daring, and resilience. The probes captured not just the planets and moons of our solar system, but also the imaginations of millions of people here on Earth. They are true trailblazers. The first objects ever launched by humanity to venture this far into the unknown. Their mission was to head beyond the reaches of our solar system and venture into interstellar space, to capture things we had never even dared to see up close. The project scientist Edward Stone summed it up when he said that looking back, humanity barely knew anything about the solar system before these missions. Again and again, these machines found things we had no clue existed. Their discoveries made everyone realize that we were looking at just a tiny slice of a much larger cosmic puzzle, a puzzle with more mysteries than answers. These two probes were born from an idea that came to life in 1977, when NASA took advantage of a rare planetary alignment that only comes around once every 176 years. It was the perfect setup, a rare alignment of Jupiter, Saturn, Uranus, and Neptune that would let spacecraft jump from planet to planet, using each one's gravity to speed up and change course. So the explorers launched, the second craft on August 20th, and the first shortly after on September 5th, and they set out on an adventure that, truthfully, no one could have anticipated would still be going strong nearly half a century later. The initial purpose of these explorers was to study Jupiter and Saturn, and maybe, just maybe, Uranus and Neptune if everything went well. Their planned mission was supposed to last 5 years. But here we are, almost 50 years later, and they are still out there cruising into interstellar space. This was only possible because NASA engineers made a series of forward-thinking design choices. The probes were built with resilience in mind. They were equipped with technology that seemed almost ancient compared to what we have today. But it was effective. Each was powered by radioisotope thermoelectric generators, which allowed them to keep going long after any typical spacecraft would have run out of juice. These generators turned heat from decaying plutonium into electricity, giving the explorers enough power to keep running for decades. Now think about this. When these probes left Earth, their computers had less memory than the key fob used to start your car. In fact, they are still using 8-track magnetic tapes from the 1970s to store and send data. This was state-of-the-art back then, but it is laughable compared to even the simplest modern device. And yet somehow these tapes and instruments keep working, running smoothly despite being subjected to the freezing, radiation-heavy conditions of deep space. They were designed for flexibility and backup. Each craft was equipped with 11 scientific instruments, many of them with redundant systems, so that they could be turned off to save power or switched on when needed. In total, each explorer had 16 hydrazine thrusters, 8 primary and 8 backups, which proved vital to the mission's success. Imagine this. The second probe's main thrusters stopped working after 37 years of continuous operation, but the backup thrusters kicked in perfectly, after having been idle for 4 decades. It is a testament to the genius, engineering, and foresight of the team that built them. By 1979, the first probe reached Jupiter, getting close enough to give us images that stunned the world. Before these missions, no one had seen the planets up close, and this kind of detailed look at Jupiter's turbulent atmosphere and its moons left scientists slack-jawed. They expected to see a planet with clouds and storms, but the swirling chaos of the planet's iconic Great Red Spot, along with a series of smaller storms, more like miniature versions of the massive maelstrom, was far beyond their expectations. These probes saw a dynamic world of high-velocity winds, far stronger than anyone anticipated, and a planet unlike any we had imagined. The next big shock came with the flyby of Jupiter's moon Io. When scientists examined Io, they did not see the same kind of crater-pocked surface as Earth's moon. Instead, they saw bright, colorful volcanic activity. Io was alive, covered in active volcanoes that sent plumes of gas and sulfur flying into space. This was a moon with a character all its own, and it reshaped how everyone thought about moons in our solar system. And then there was Europa, an icy world with an enigmatic surface that hinted at something hidden beneath. The lines and cracks on Europa's surface hinted at liquid water, maybe even an ocean, lurking below the ice. This was the start of one of the greatest space mysteries of our time. Could there be life in an ocean beneath the ice of a distant moon? These spacefarers gave us the first glimpse of that possibility. With Jupiter explored, the Voyagers moved on to Saturn, ready for more discoveries. Saturn's secrets and Titan's enigmatic haze. After the journey past Jupiter, the probes headed to Saturn, one reaching it in 1980, followed by the other in 1981. Saturn turned out to be just as mysterious and intriguing as Jupiter. Its rings, believed to be 5 major ones, revealed hundreds of thin, intricate ringlets. They were not just randomly spread around either. Some displayed dark spokes, shadowy features that puzzled scientists initially. These rings weren't just a static feature of Saturn, they were dynamic, ever-changing. Saturn's moon Titan also became a focal point. Data from the probe revealed that Titan had a thick, nitrogen-rich atmosphere, the only moon in the solar system to possess such a characteristic. The orange-hued haze completely enveloped Titan, hiding its surface from view, but it was enough to spark questions. What could lie beneath that haze? Decades later, it fueled the motivation for the Cassini-Huygens mission to dive deeper into exploring Titan. By 1986, the second craft had reached Uranus, a planet with an almost serene, featureless blue-green atmosphere that seemed to defy expectations. The data it sent back revealed Uranus had an unusual magnetic field, tilted at almost 60 degrees from its rotational axis, causing it to behave in bizarre ways. This was the beginning of a realization that our models of planetary magnetic fields needed significant revision. The next stop was Neptune in 1989, where the second probe delivered another surprise, the Great Dark Spot. Like Jupiter's storm, Neptune hosted a massive, swirling storm system, but in this case, it was dark and mysterious. Observations from the craft revealed wind speeds faster than anything ever recorded before, up to 2,400 kilometers per hour, far beyond what scientists had imagined could exist on a planet. And then there was Triton, Neptune's moon. It was the coldest known object in the solar system, with geysers that spewed nitrogen gas and a surface marked with rugged, mysterious terrains. Triton was a moon full of questions, and the spacecraft offered humanity its first close-up look. After Neptune, the path of the second probe turned downward, out of the plane of the solar system. Like its counterpart, it was now on its final journey into interstellar space. Meanwhile, the first craft had already begun its own voyage into the unknown. In 1990, it turned its camera around one last time, at Carl Sagan's urging, and captured a photo of Earth from 6 billion kilometers away. That image, the pale blue dot, became one of the most iconic photographs in history. For years, the two explorers have continued their journey through the outer edges of our solar system, crossing the boundary known as the heliopause. The first craft crossed into interstellar space in 2012, and the second followed in 2018. They became the first human-made objects to do so, providing data that challenged long-held assumptions about the boundaries of our solar system. The heliopause was not smooth and clean. It was turbulent, chaotic, far from what scientists expected. In recent years, the first probe experienced an unexpected glitch. It began transmitting strange, garbled signals, data that didn't make sense, suggesting confusion about its own orientation. Yet its antennas kept pointing toward Earth, and data continued arriving, though scrambled. After months of analysis, NASA discovered the craft had somehow switched to an older, inactive computer to transmit data, which they were able to correct, at least for now. But the duo is aging. They are starting to fail bit by bit. In 2025, they are expected to finally run out of power, their plutonium fuel exhausted after nearly 50 years of service. They will go silent, but they will not be gone. These spacecraft will continue drifting forever. Long after Earth has disappeared, long after humans are forgotten, the probes will keep wandering, carrying their golden records, a message in a bottle to the cosmos, with greetings in 55 languages, music, and images portraying life on Earth. Someday, perhaps thousands or even millions of years from now, an alien civilization may find one of these travelers. They will learn a little about who we were and what we dreamed of. But for now, we must bid farewell to these brave explorers and thank them for the wonders they have unveiled. The journey of these spacefarers into interstellar space is unlike anything else humanity has achieved, made possible by careful planning, a bit of luck, and an enduring curiosity that pushed us to explore beyond our tiny corner of the universe. When these explorers were being designed, NASA had to balance ambition with practicality. The engineers knew these missions could stretch on for decades, perhaps even further than initially planned. So they built machines that would outlast their own careers. Each probe is powered by 3 radioisotope thermoelectric generators, and when they launched, they produced about 470 watts of power. But over time, that power output has declined. The decaying plutonium, 238 inside each generator, has a half-life of 87 years, meaning the energy produced gradually diminishes. Even so, these machines have held up far better than anyone dared to hope. And in 2024, they are still able to collect and transmit scientific data. The journey into the heliosheath, the outermost layer of the sun's influence, was a challenging one, full of surprises. The sun's magnetic field creates a massive bubble around the solar system, and the boundary of that bubble is chaotic and turbulent. The first craft crossed the termination shock, the point where the solar wind suddenly slows down, in 2004, followed by the second in 2007. This region, known as the heliosheath, is where the solar wind piles up and becomes compressed, creating a hotter, denser area. It is a strange, unpredictable place, filled with magnetic bubbles and waves of energetic particles. After Saturn, the Voyager set course for Uranus and Neptune, revealing even more surprises. Messages from a forgotten world. Crossing into interstellar space, both Voyagers encountered something unexpected. The sun's magnetic field lines did not simply stop at the heliopause, but appeared to extend beyond it, twisted and stretched by interstellar winds. The data from the first probe showed that the magnetic fields inside and outside the heliopause were aligned in ways that baffled scientists. They had expected to see a change, a distinct boundary, but instead the field lines seemed to merge, suggesting that the environment beyond the solar bubble was more connected to our sun than anyone had thought. Even as they ventured farther from the sun, these explorers never lost their purpose. In fact, they became even more valuable. They carried instruments to measure cosmic rays, magnetic fields, and plasma properties. Though not cutting-edge technology by today's standards, the equipment was simple, rugged, and designed to withstand harsh conditions. And withstand it did. The cosmic ray instruments on these craft detected particles from distant supernovae and the galactic core, offering insight into the broader universe that would be impossible to gather from Earth or even near Earth orbit. These emissaries have also faced numerous challenges. Their technology is aging, their power supply dwindling, and communication becomes increasingly difficult. It takes over 21 hours for a signal from the first probe to reach Earth. In a sense, they are like ancient ships, slowly sailing into the uncharted seas of interstellar space, alone and cut off from direct assistance, relying entirely on their own systems and a distant team of engineers on Earth who work tirelessly to keep them alive. The day will come when these spacefarers go silent, but their story will continue. They carry golden records, messages intended for any intelligent beings who might one day find them. These records contain music, greetings, and images from Earth meant to tell the story of our world. It is a gesture of hope, a belief that perhaps one day, someone, somewhere, will find these small craft and learn about the civilization that created them. The golden records were designed to last at least 1 billion years in the cold of space. Made of copper and plated with gold, they contain instructions for playing them. They feature greetings in 55 languages, music from many cultures, sounds of nature, and images capturing the diversity of life on Earth. Carl Sagan, who helped design the records, called them a bottle in the cosmic ocean, an apt description. These pioneers drift farther and farther, carrying a message about who we were, what we valued, and what we dreamed of. The first probe is now the most distant human-made object from Earth. It has already left the heliosphere, a vast bubble of particles and magnetic fields created by our sun, and is now cruising through empty space, heading toward a star called Gliese 445. This red dwarf star, located in the constellation Camelopardalis, is around 17 light-years away. In approximately 40,000 years, the probe will pass within about 1.5 light-years of it. By then, Gliese 445 will have moved slightly closer due to the motion of stars. But it will still be a mere flyby. This craft will continue its journey silently, like a traveler with no destination, passing by unnoticed. The journey of this lone explorer is not just about distance, but also about time. 40,000 years, a span so vast it defies imagination. By then, written human history as we know it will be ancient. Current societies may be long forgotten. The continents may have shifted, climates may have changed dramatically, and humanity, if it still exists, may have evolved in ways unimaginable today. Yet there this craft will be, still traveling, a small piece of metal carrying the memories of a time when humans first looked to the stars with the ambition to explore. Meanwhile, the second spacefarer took a different path after exploring the outer planets, and it too has a stellar rendezvous ahead, around the same 40,000-year mark. It is on course to pass near Ross 248, another red dwarf about 10 light-years away in the Andromeda constellation. Like Gliese 445, Ross 248 will remain oblivious to the passing spacecraft. For these stars, the probes are mere waypoints on an endless journey. The second craft also carries its own golden record, a time capsule from Earth, containing greetings in various languages, music from diverse cultures, and the sounds of wind, waves, and other aspects of nature. This record encapsulates Earth as it was at the time of the launch, a hopeful message in a bottle sent into the ocean of space. After Ross 248, it will keep drifting, moving farther and farther away until our sun becomes just another faint star in its path. The magnitude of this mission is almost beyond belief. These two small craft, each roughly the size of a car, are traveling distances and timescales that are nearly impossible to fathom. 40,000 years ahead lies a future more distant than anything we can imagine today. Civilizations may rise and fall, the world may transform beyond recognition, and even new forms of life may emerge. And still, these explorers will remain out there. They are our silent pioneers, traveling through the galaxy long after everything we know has changed. They carry a piece of us, our curiosity, our urge to explore, and our hope that we are not alone in the universe. After their encounters with these stars, the craft will not simply stop. They will continue to cruise through the galaxy, becoming part of the Milky Way's orbit, tracing vast loops across space for millions of years. Unlike planets or asteroids that may crash or be torn apart by gravitational forces, these explorers are likely to keep traveling. They are our messages to the future, symbols of an era when a species on a small blue planet chose to look beyond its sky and seek to understand what lay beyond. Quiet and solitary, they stand as proof that once, humanity dared to reach out into the vast unknown. Even millions of years from now, when our sun is a distant speck, these explorers will still be moving through space. They will drift by countless stars, and maybe, just maybe, one day they will be found. Perhaps an advanced civilization will encounter these relics from another time and learn something about us. Or perhaps they will journey on forever, untouched and unnoticed, as monuments to the moment when humanity first reached for the stars. Small, fragile, yet incredibly resilient. They are a testament to the time when a curious species dared to explore beyond their world, carrying the dreams and questions of humankind into the cosmic expanse. Could the Voyagers be our most enduring legacy, or just a forgotten whisper in the vastness of space? If this makes you think, leave a comment and subscribe for more.